There is a point so far from Earth that sunlight no longer feels like home, a place where the solar system begins to fade, where the sun's influence becomes only a distant memory, and where human technology should have stopped functioning long ago. Yet one spacecraft remains there, still awake, still sending signals across the darkness. Voyager 1 was never expected to travel this far. It was built for a relatively short mission, a brief tour of the outer planets, a few years of scientific exploration, and then silence. Instead, it continued onward, past Jupiter, past Saturn, beyond the protective bubble created by the sun, and into the vast emptiness between the stars. Now, in interstellar space, Voyager 1 is detecting something no human has ever directly observed before, a faint, persistent hum resonating through the plasma that fills the space between the stars. It is not a voice. It is not a message. It is something even stranger, a subtle background resonance of our galaxy itself. Voyager 1 began with surprisingly modest expectations compared to what it ultimately achieved. Launched in September 1977, its original mission was to spend only a few years exploring Jupiter and Saturn, photographing these giant worlds, transmitting scientific data back to Earth, and eventually fading into silence as its systems gradually failed. No one designed it to become the most distant human-made object ever created. No one expected it to survive for nearly half a century. Yet that is exactly what happened. Part of its success came down to extraordinary timing. Approximately every 175 years, the outer planets align in a rare configuration that makes a grand tour of the solar system possible. By carefully using the gravity of one giant planet after another, a spacecraft can gain speed while conserving fuel, allowing it to travel much farther than would otherwise be possible. Voyager 1 and its twin, Voyager 2, were specifically designed to take advantage of this once-in-many-lifetimes opportunity. NASA recognized the rarity of the planetary alignment and launched both spacecraft to exploit it. Even in the earliest days of its mission, Voyager 1 was already surpassing expectations. Just days after launch, while millions of kilometers from Earth, it turned its camera back toward home and captured the first photograph ever taken of Earth and the Moon together from deep space. It was a symbolic image, an early indication that Voyager would become more than just another scientific probe. It would become humanity's witness, carrying our curiosity farther into the universe than anyone had imagined possible. Voyager 1 earned its legendary status not simply because it survived, but because of what it discovered along the way. When it reached Jupiter in 1979, the spacecraft confirmed that the Great Red Spot was not merely a colorful marking but an enormous storm larger than Earth itself, one that had been raging for centuries. It unexpectedly discovered Jupiter's faint ring system, identified previously unknown moons, and made one of the most astonishing discoveries in planetary science. On the moon Io, Voyager observed active volcanoes erupting in real time, the first volcanic activity ever seen anywhere beyond Earth. Then came Europa. Its smooth, fractured icy surface resembled broken sea ice floating across a frozen ocean. Those images inspired one of the most important scientific ideas of the modern era. Beneath Europa's frozen crust might lie a vast liquid ocean, potentially creating one of the most promising habitats for life elsewhere in the solar system. Voyager 1 had been sent to study planets, but instead it was raising entirely new questions about the possibility of life beyond Earth. Its discoveries continued at Saturn. The spacecraft revealed that Saturn's rings were not just a handful of broad bands but thousands of delicate ringlets sculpted by the gravitational influence of nearby moons. It also transformed Titan from a hazy orange blur into one of the most fascinating worlds in the solar system. Titan possessed a dense atmosphere cold enough for methane to behave much like water does on Earth. There were methane clouds, methane rain, and an entire weather cycle based on chemistry that seemed strangely familiar despite existing in an environment utterly unlike our own. To study Titan closely, mission planners made a decision that would permanently change Voyager 1's destiny. They redirected the spacecraft onto a trajectory that carried it out of the plane of the solar system, sacrificing any opportunity to visit additional planets. In exchange, Voyager 1 would become the first spacecraft ever sent toward interstellar space. For decades, scientists believed the outer edge of the solar system would be a broad and gradual transition. The sun constantly releases a stream of charged particles known as the solar wind, inflating a vast protective bubble around the planets called the heliosphere. Beyond that bubble lies interstellar space. Researchers assumed the boundary between these two regions would be diffuse, slow, and difficult to define. Voyager 1 discovered something entirely unexpected. In August 2012, the transition occurred suddenly. The number of solar wind particles dropped dramatically. Galactic cosmic rays surged. The surrounding magnetic environment changed. Within roughly 2 days, Voyager crossed from one region into another as though it had passed through a thin membrane. It was not a gradual fade into deep space. It was a remarkably sharp and well-defined boundary, far more distinct than scientists had predicted. For the first time in history, a human-made object had entered interstellar space. What Voyager found there was not empty nothingness. The interstellar magnetic field proved to be much stronger than expected, pressing against the heliosphere with significantly greater force than existing models had predicted. In other words, the galaxy beyond our solar system was not quiet or passive. It was pushing back. The sun's protective bubble was not expanding freely into empty space. Instead, it was maintaining its shape against a far more structured, energetic, and dynamic interstellar environment than anyone had previously realized. Among all of Voyager 1's discoveries beyond the heliopause, one stands out as especially mysterious. Between 2017 and 2020, the spacecraft detected a steady, low-frequency hum at approximately 3 kHz.